In this third segment, we are going to be discussing the digestive system, the function, the organs that make up the digestive system, and then the role that nutrition plays in the digestive system. So before we get into the digestive system, let's talk a little bit about taste and food consumption. Well, there are 5 basic chemical tastes, which you've probably heard about all of these before. So we have our sweet, our sour, our bitter, salty, and then umami, which is our 5th chemical sense, which is basically an Asian word for savory. For most people, sweet, salty, and fatty foods are universally desired, so there's usually this aversion to bitter or sour taste. Some people may actually have a genetic component where they, don't like certain bitter foods like Brussels sprouts. Even over time, they may never like those foods. So some foods we can become accustomed to, and we may like them after multiple exposures, but some people have this strong aversion to bitter and sour taste and may never overcome that. So because sweet, salty, and fatty foods are universally desired, this can lead to a drastic overconsumption or overeating of these substances, and this can have some major health consequences. So if we think about what sweet, salty, and fatty foods contain and how this can have an impact on our health. So for sweet foods, these are going to provide us excess energy, so those discretionary calories we've talked about, those empty calories. Fatty foods are obviously going to be providing excess fat, and again, probably some discretionary or empty calories. And then salty foods are providing excess salt. And most of us, our sodium consumption is already too high, so this can be a negative consequence over a long period of time because this could lead to high blood pressure. Alright, getting more into the digestive system itself. The digestive system is composed of organs that are breaking down or digesting complex food particles into these smaller absorbable products. So here you can see the definitions of digesting and absorbing. You can review these in your text as well. So the digestive system is composed of the digestive tract as well as some accessory or ancillary organs. So the digestive tract may also be called the alimentary canal, and this is really a flexible muscular tube. It's about 26 feet long, and it extends from the mouth to the anus. So you can see all the different organs that are included within the digestive tract. These accessory digestive organs include things like the salivary glands, the liver, the gallbladder, and pancreas. And we're going to talk about all of these different organs as they relate to the digestive system in the coming slides. So before we get into these organs, there are 2 types of digestion. There's really these 2 levels. So we have mechanical digestion and chemical digestion. So let's start with mechanical. Mechanical is really the chewing, the mixing, the moving around of food. So it begins in the mouth with chewing. So our saliva is moistening the food, and it's going to moisten the food and make it into a ball called a bolus. The stomach and small intestine are the locations for liquefying the foods by mashing and squeezing, and in the stomach, when we have this combination of everything, it's called chyme, and the chyme is going to be transported from the stomach to the small intestine. In the large intestine, we have reabsorption of water going on, and then absorption of minerals. And then the rectum is going to store the feces until excretion. So basically everything that is left over in the large intestine is going to be moved to the rectum, stored as feces, and then excreted from the body eventually. So mechanical digestion and digestion in general is basically going on all of the time. It's really only limited during sleep time and then during exercise. So if you eat too late at night, so you may have heard, if you eat after 8 p.m., you're going to gain weight, or, anything you eat after 8 p.m. goes straight to fat. That's not necessarily true. But if you eat too late, this can cause your food not to be digested properly. And so it's just going to impact your digestion. Also, when you exercise, this is one reason you don't want to eat a big meal right before you exercise, because exercise is going to limit digestion as well, and then you may have some negative consequences with that as well. So another term just to know with mechanical digestion is peristalsis. which this is the wave-like muscular squeezing of the esophagus, the stomach, and the small intestine that is pushing the contents, or our bolus, throughout the digestive tract. So you can see this picture really represents peristalsis. So, it's just these wave-like contractions. So we have our big long tube here, which is our esophagus, the swallowed food, or our bolus, which is B-O-L-U-S if you want to look up and learn a little bit more about that. So it's just squeezed and moved. There's no breakdown going on. It's just the movement piece down the esophagus to the stomach. Alright, so getting into chemical digestion. This is when things are really being broken down. And the piece with chemical digestion is that enzymes are involved. So digestive juices are going to contain enzymes that break down nutrients. And this is where our accessory organs come in. So our salivary glands, the pancreas, liver, again, are accessory organs, and we still have our stomach and small intestine. So the salivary glands are going to secrete saliva. So saliva is involved with the health of our teeth, so it can also wash away food particles and then neutralize any acids produced by bacteria. But it also produces two very important enzymes: salivary amylase, which is going to start the breakdown of starch or carbohydrates, and then salivary lipase, which is going to start the breakdown of fat. There is no breakdown of protein in the mouth. Once the food gets to the stomach, which is a very acidic environment, we see gastric juices, and the gastric juice is a mixture of water, enzymes, and hydrochloric acid. Hydrochloric acid is going to start breaking down protein digestion. There's really no other lipid or fat breakdown or carbohydrate digestion going on in the stomach. It's primarily protein digestion. So again, the stomach is very acidic, but the stomach itself isn't being digested because the walls are protected by mucus. Alright, next we have the small intestine, which is basically the organ of digestion and absorption. So a lot is going on here, and you'll see the transit time in a couple of slides, how much time food really spends in the small intestine. So a lot of the accessory organs are secreting their enzymes, and then they're going to the small intestine. So bile, for example, is secreted by the gallbladder, and it emulsifies fats. So in the small intestine is where we're going to see more breakdown of our fats or lipids. Bicarbonate is secreted by the pancreas. So bicarbonate is a base. So we know that our stomach was very acidic, and then that chyme, that big the liquidy mixture, is being passed to the small intestine. The small intestine is a very basic environment. So the bicarbonate is helping to neutralize that acidic chyme that's coming in from the stomach. The small intestine is the major site for carbohydrate, fat, protein, vitamin, and some mineral absorption. And then the large intestine is where the rest of the minerals are going to be absorbed. Water is going to be reabsorbed. And then fiber is also going to be broken down by different bacteria in the large intestine as well. So digestion is really efficient. This is the body knows what it's doing. Your body adjusts to whatever mixture of food it is presented with. So it doesn't matter if you eat, chocolate cake and a cookie and ice cream, or you eat a balanced meal of whole wheat pasta with meat sauce and tomatoes and a side of veggies and a salad, or if you just ate something that had a whole bunch of, if you just ate a pound of butter. Your body's going to adjust to whatever mixture of food it's presented with. So the pancreas will adjust whatever digestive enzymes based on the nutrient content of the food. And then within 24 to 48 hours of eating or consuming something, 90% of the energy nutrients are going to be digested and absorbed. So remember, those energy nutrients are carbohydrates, fat, and protein. This picture does a nice job demonstrating about how much time food spends in each area, and we'll go through these as we really walk through the digestive system. So the mouth, for this I would reference you to your textbook. There's a really good example of, if you eat a peanut butter sandwich, what happens in the body. So this is just very general, but I want you to think about if you were to consume maybe a hamburger or, that pasta meal, what's going on in your body. So we consume the food first through the way of our mouth, and the food stays in the mouth for less than a minute. And remember, here is where food is being crushed and mashed and mixed with saliva by our teeth. Carbohydrate digestion is going to begin by salivary amylase. A little bit of fat digestion is going to begin with the salivary lipase, but remember, no protein digestion is occurring in the mouth. Once the food is mixed with the saliva, we have our bolus or our ball of food, and we're going to swallow that, and it's going to move by way of peristalsis down the esophagus to the stomach. The food is going to be in the stomach for 1 to 2 hours, so it's passing from the esophagus through the lower esophageal sphincter. Once the food is in the stomach, there's no further digestion of carbohydrates, and the gastric juice is going to mix with that food or that bolus. The proteins are going to start to break down here, so by proteases, which are protein breaking down enzyme, and then all the food is going to form that liquid substance that I talked about called chyme. Chyme will then pass through the pyloric sphincter into the small intestine. And again, the small intestine, remember, is the site for digestion and absorption. So the food is going to spend 7 to 8 hours here. Remember, bile is going to come in from the gallbladder to help emulsify and break down fats further. The pancreas is sending bicarbonate and other digestive enzymes to help break down fat, protein, and starch. So all of our major macronutrients or all of our major energy-yielding nutrients are going to be broken down in the small intestine. Vitamins and minerals are also going to be absorbed, and then the contents will pass through the ileocecal valve into the large intestine, where the food will remain for another 12 to 14 hours. So basically everything, all the contents are just sitting there. Fluid is going to be absorbed, fiber is going to be absorbed, some more minerals will be absorbed, and then eventually all of that will be stored as feces until it's ready to be excreted by the body. And we'll talk about the excretory system in our next segment. A little bit about absorption. Nutrient molecules are absorbed, throughout the small intestine. Water-soluble components are going to be absorbed through the blood, and fat-soluble components are going to be absorbed and transported through the lymph. The cells of the small intestine are very selective, so they recognize the nutrients that might be in short supply. So if you have a low intake of something like calcium, your cells are going to recognize that there's not a lot of calcium, coming in, so they're going to make sure that they absorb whatever calcium is there. So they're very efficient. The small intestine also has these folded structures called villi, and which are the finger-like structures. And then on the villi are these microvilli, which are the hair-like structures. So these help to increase the surface area of the small intestine and really help and aid in increasing the surface area and absorption of things like fiber, protein, and carbohydrate. As far as transport goes, again, lymph vessels are dealing with our fat digestion, products of fat digestion, fat-soluble vitamins, which we'll talk more about in future lessons. Blood vessels are more with carbohydrate and protein digestion and most vitamins and minerals. The digestive tract is very sensitive to malnutrition, so if you're not getting enough energy or protein or carbohydrate, your digestive system is going to be a little bit out of whack as well. So how does the digestive system relate to nutrition? If this is your system for the week, these are some conditions or diseases to think about, and how do they relate to proper nutrition. So things like celiac disease, these individuals can't consume gluten, and if they consume gluten, it actually can damage those villi in the small intestine and decrease their absorption of other important vitamins and minerals, and so these individuals may be deficient in things like iron or other minerals and vitamins. Thinking about constipation, fiber is related to a healthy digestive system to keep us regular. Heartburn, some people may be a little sensitive to spicy foods. So these are just some conditions to consider if the digestive system is your system to talk about for the week. So good luck with that. And I hope that now every time that you eat something, you think about how it goes through your body, what's going on mechanically, what's going on chemically, and then how does your body use that energy.